In today's lecture, Lecture 7, we're going to be talking about the classification of living things. We're changing gears here with this topic. We've been dealing with astronomy, then geology, then alchemy and chemistry. This is our first real contact with the biological sciences. So, as I promised you in the opening lecture, we'll back up to set the stage for our considerations as we do these various passes over the 18th century. Now, the fact that you're listening to me on this tape means that you are already familiar with the teaching company. If this is your very first teaching company course, then you probably don't know a whole lot about other offerings. But many of you, I suspect, are already aware that there is a course in history of science devoted to the chronological eras prior to this course. For those of you who didn't know this, Professor Lawrence Principe from Johns Hopkins University has completed a course for the teaching company on the history of science prior to 1700. In that course, Professor Principe described the explosion in the number of plants and animals recognized during the 16th and 17th centuries. He talked about how the proliferation of knowledge of the world of living things during these times created what he called an information overload. He also noted that the invention of the microscope made possible new knowledge of the internal structure of plants and animals. So this was an area that had received a lot of attention prior to the 18th century. Professor Principe emphasized that natural history emerged during this period as part of natural philosophy, in which plants and animals represented a collection of individual objects of interest in their own right. Well, what had they been if they had not always been something that had their own meaning? Prior to this time, in the Middle Ages, plants and animals had been regarded primarily as emblematic of some religious or moral truth. They didn't possess intrinsic interest on their own as much as they were vehicles for higher meanings. One didn't care so much about plants and animals themselves. What was important was the lesson they symbolized. According to Professor Principe, that changed in the 16th and 17th centuries. Natural history became a part of natural philosophy, and plants and animals took on an interest of their own. I refer you to Professor Principe's lectures if you want to learn more about this. In this lecture, we're going to investigate what became of the information overload about plants and animals in the 18th century. First, we'll look at some of the conceptions 18th century naturalists inherited from their predecessors regarding the organization of living things. Then we'll focus on the life and work of Carl Linnaeus, sometimes called the father of classification. With Linnaeus's work, we'll be branching out from Central and Western Europe, where we've spent our time so far. We'll be going to Scandinavia, Sweden in particular, to get a feel for some of the things that were happening there. And when we've finished looking at Linnaeus, we'll ask about the impact of these developments on the age, that is, on the Age of Enlightenment. Okay, so what were some of these conceptions from the past that helped shape the context in which 18th century naturalists attempted to organize the wealth of new knowledge about the living world? One of them went back all the way into the ancient tradition, to the Greek conception. I'm thinking here particularly about the Platonic tradition, in which it was understood that the cosmos had a divine origin. Because of the way the physical world and everything in it had originated from the mind of God, there was nothing missing. This was especially the case with the world of living things. In a book called the Timaeus, Plato had written that the living world was complete. And that could only be, he said, if it contained all sorts of living creatures. Now, as this notion filtered down to the Latin West, it had come to mean that everything that could exist did exist. One could think of God's creatures as arranged in a staircase or ladder of being, the so-called scalae naturae, and no steps or rungs had been bypassed. To say otherwise would be to say that something had been overlooked or maybe omitted, left out, perhaps even forgotten. That would imply that God had made a mistake, that God had neglected to create some beings that could have taken their place among the living things. A long time ago now, a historian named Arthur Lovejoy characterized the view of the world of organisms that resulted from this perspective as a great chain of being, proceeding from the simplest forms of life upward until it reached the Godhead itself. So the great chain of being was the arrangement of living things from simplest organisms up to God. In his book, he cites the English philosopher John Locke, who captured this sense in one of his writings. In his essay concerning human understanding, he wrote the following. Now, I'll try to give you the words slowly so you can follow the 17th century English. Incidentally, listen to where human beings are in this ascending chain. Locke said, "In all the visible corporeal world, we see no chasms or gaps. All quite down from us, the descent is by easy steps. And until we come to the lowest and most unorganical parts of matter, we shall find everywhere that the several species are linked together and differ but in almost insensible degrees. And when we consider the infinite power and wisdom of the Maker, we have reason to think that it is suitable to the magnificent harmony of the universe that the species of creatures should also, by gentle degrees, ascend upwards from us towards His infinite perfection, as we see they gradually descend from us downward." Did you pick up where we humans are in the great chain of creatures? We're right in the middle. Locke says that the descent by gentle degrees down from us to the lowest forms and then up from us, presumably through hosts of angels to God, is consistent. I once heard someone say that if you take the average between the smallest things we can conceive of, quarks, and the largest, perhaps some galactic region, that if you average those two dimensions, you get about 2 meters, the size of a human being. Well, first of all, I'm not sure that's true. What I am sure of is, even if it is the case, its relationship to John Locke is pretty fortuitous, but it's an interesting idea. Well, let's move on. There was another conception that naturalists in the 18th century inherited that was very important. This was the assumption that the perfection that marked the original creation had not changed since the creation. All the creatures God made in the creative decree were as God intended them to remain. Now, what's implied in this? A lot. Suppose I suggest, for example, that some species had come into being at some point after the original creation. That idea, incidentally, is what was meant by the notion of an origin of species, that some species had originated subsequent to the original creative decree. To say that implied that God had forgotten to include them the first time around. It would mean that there had been a gap in the original chain of being that was filled only later. So we can't have an origin of species. This idea of the original perfection also implied that the array of species God had originally created had not changed by a species going out of existence. In the great chain of being, there were no missing links. Nothing had gone awry to cause God's original plan to lose track of a species. No, the great chain was as God made it and intended it to remain. So, no new species, no species going extinct, and of course, no species changing over time into a different species. This understanding has been called the doctrine of the fixity of species. As it came down to the 18th century, then the fixity of species was the notion that species cannot become extinct, new species cannot originate, and no species can be transformed into another. These were important conceptions of the world of living things that came down to the naturalists of the 18th century. Once again, we see how central to the development of natural science Western religious ideas were. But the 18th century, as we have seen already a lot in these lectures, had folks interested in trying to figure out how God had gone about his work. We've seen that in the theories of the earth, and astronomy, and the geological ideas that we've explored. Well, it was true in the world of living creatures as well. Here it showed itself when naturalists asked themselves whether it was possible to depict the natural order underlying the living world. Could one specify a taxonomy that reflected accurately how organisms related to each other? Perhaps even the plan God had followed? Now, I promised you we were going to Sweden, and that's exactly what we'll do. Among those who took up this question of a natural order in the 18th century was a Swede named Carl Linnaeus. That's the Latinized version of his name. It's Carl von Linné. But Linnaeus is the name we know him by, and Linnaeus has become a famous person in the history of science. He's known as the father of classification, as I said. But his traditional family name wasn't Linnaeus. That name had been unknown among his ancestors before his father, whose name was Nils Ingemarsson, had given the name to Linnaeus, to himself in tribute to a linden tree growing next to the family farm. So it was a relatively new form of the name. Carl's parents hoped that Carl would go into the Swedish Lutheran ministry. But like so many children, he disappointed his parents and wanted to do something else. You see, Carl's father was a Swedish curate, and his mother was the daughter of a pastor, so it was naturally expected that he too would become a pastor. It was in the family blood. But when he went off to the university in the fall of 1727 at the age of 20, Carl chose medicine as his field of study. Now, don't misunderstand here. Carl was not, at least in his own mind, rebelling against the religion of his parents when he went into medicine. Linnaeus would always remain a very religious person. That heritage he retained from his parents. Carl's father influenced him in another way, too. His father was an avid gardener. Not only so, he deliberately encouraged the same love of plants in his son. So when Carl decided to abandon the plans for the ministry that his parents had for him and to study medicine, eventually focusing on the area of botany, he didn't at all see this as rebelling against his religious upbringing. That was because he regarded his later occupation with botany as a religious calling. In fact, he developed a confidence that could come across as arrogance. And with reason, because he sometimes even saw himself as called by God to reveal the laws of nature to others. So off to Lund University he went, and from there he went on to Uppsala. In Uppsala there was a herbarium of 3,000 species, something that really attracted him. A library was another matter. It wasn't much. Many of the holdings were woefully outdated, but Linnaeus was able to get hold of botany books in the private library of one of the professors, and he made good use of them. Now, it wasn't long before Linnaeus decided, even this early in his training, that the botanical work he had been reading was inadequate. Shades of that arrogance I spoke of earlier. He determined that he would take on the task of describing all flowers accurately. Sometimes it takes the cockiness of youth to embark on a major undertaking of this sort. Linnaeus said that what he was going to do was to bring flowers into new classes and to reform name and genera in a completely new way. Now, this decision didn't come out of the blue. It was not as if he was not dependent on those who went before him. Nobody works in a vacuum. In his case, it was apparently reading about the French botanist Sébastien Vaillant in his work on plant sexuality. And that was the occasion for Linnaeus' decision to erect a new system. Vaillant lived from 1669 to 1722, so he had died before Linnaeus went off to the university. Linnaeus read a magazine review of a lecture Vaillant had given in 1717. He was unaware that at least 3 others before Vaillant in the 17th century had also discussed the sexuality of plants. So when Linnaeus too became convinced that plants had sex, he was hardly the first person to think so. But he was going to make it the key to his new system. Once again, we see the personality I mentioned coming through. Throughout his career, he would always downplay his dependence on others wherever possible. That would prove to be typical of him. He didn't like acknowledging the work of Vaillant. Now, I don't mean to diminish what he did accomplish, because he created a new system. That will become apparent shortly. It was in the early 1730s that as a young student, he wrote out his first thoughts on a sexual system of plant classification. Here's how he justified it. He argued that nature itself proclaims sexuality should be the basis for classification because fruiting occurs so consistently. Well, how did his system work? In his system, he used the number of stamens that's the male pollen-bearing organs of a flower, and their relation to each other as the basis of the major divisions of plants into classes. For example, class 14 of the flowering plants include those whose stamens are arranged in a specific way. In particular, if there are two stamens adjacent to each other that exceed the others in size, they belong to class 14. By 1735, he'd written the first edition of his book, which would be called System of Nature. This was just a slim book in the first edition, but it grew in later editions into a multi-volume classic that made Linnaeus famous. I mentioned to you earlier that the question of a natural order, the plan God employed when God created living things, was an ultimate goal of naturalists. Linnaeus had that goal, but he conceded that his system was not the natural order that he and others ideally sought. It was a taxonomy based on one characteristic, sexuality, not a complete set of characteristics. This idea of a natural classification, the classification of organisms based on the collection of their characteristics that reflects the order God imposed, that eluded him all his life, even though he called it the first and last goal of botany. Linnaeus was clear that he was creating an artificial system, but he believed that its merits would be clear because it was going to be easy to use. In this same year, 1735, Linnaeus went to Holland, and it was there that he actually received the medical degree he'd been pursuing. He stayed there 3 years, studying and corresponding with some of Europe's botanists and refining his classification work. And then he came back to Sweden in 1738, practiced medicine for 3 years, and then finally, in 1741, he was offered a position as a professor of medicine at Uppsala. And here he would remain a professor for the rest of his life. Now, as he worked on his system of classification, Linnaeus introduced a refinement that eventually would standardize botanical nomenclature. It comes in various writings from around the middle of the century. We have to appreciate what he was up against here. Say you had a plant you wanted to identify. You could look it up in one of the several books that existed in which plants were listed. These books were arranged according to the name of the plant. But, and here was the cause of the problem, there wasn't any recognized gold standard for names. So, identifying plants from the names they were given was extremely difficult. What might be listed under one name in the Genera Plantarum, which was one of these books of plants, might not be the same name used in the Hortus Cliffortianus, which was another of the available lists. So Linnaeus decided he was going to standardize things. Naturalists had, for some time, occasionally made reference to different levels of organization in nature. What I mean is that they recognized that a given plant or animal belonged to a species and that there were also groups of similar species called genera. Sometimes, in fact, they would use both names to identify a plant or animal. What Linnaeus did was to employ this technique in a systematic and consistent way. He introduced the practice into his work, The System of Nature. This had the effect of insisting that the specific name for a plant, that is, the name of the species, should do more than merely describe it. It should also differentiate it from other species that were similar to it, other species that belonged to the same group or genus. But if he were going to do this, he would have to refer to more organs than just the sexual, because the sexual organs often were virtually the same throughout the genus. So Linnaeus began systematically using this practice of giving every organism two names, one denoting its genus, the other its species. Gone were those long Latin names. What replaced them was a simpler schema. For example, one could now refer to Canis lupus, a wolf, and know that you were not talking about a tame dog. That was Canis familiaris. So it was Linnaeus' scheme, and his success in accomplishing this binomial classification system became evident from its widespread acceptance. And it brought Linnaeus a lot of attention and eventual fame. There's another aspect of Linnaeus that I want to mention, and it very much goes to Linnaeus' devotion to his native Sweden. I've already told you a little about Linnaeus' personality. He wasn't the type to sit still and wait for others to do things. He wanted to be the motive force, at Uppsala, Linnaeus saw himself as an agent of a particular kind of change. He would be the one who would improve understanding of living things, and he would do it to benefit the fatherland. He undertook much of his research, for example, as an expression of his commitment to improving the Swedish economy. How? By making it more self-sufficient. Let me tell you how he set about to do this. Among his more famous endeavors were the attempts to acclimatize plants that were not native to Sweden. Even plants from tropical regions, he wanted to acclimatize them to the Swedish environment. As a famous professor in Uppsala, he had lots of students. He would send them all over the world as his emissaries to gather information, to bring back products for his experiments. His assumption was that plant species exposed to a colder climate would develop into a stronger variety. If he were successful, then Sweden would not only be the center of this kind of research, but it could become less dependent on other countries. He was, as you might suspect, overambitious in this enterprise, but overambition was his middle name. Now, from this you might be able to see that he didn't think living things were so fixed in their characteristics that they couldn't adapt to a new environment, even if that environment was substantially different from the one they were used to. Like other naturalists, Linnaeus began to think that species were not quite as fixed as most people believed. In his case, his exhaustive study of new plants over 2 decades had brought him to a different understanding of God's work at the creation. And in the course of his work, he had observed plants with some pretty unusual features. Where had these varieties come from and these features? He thought maybe it went back to a physical basis at first. Maybe it was just a difference in the soil they grew up in. Linnaeus decided this wasn't the case, and he began entertaining the possibility that the emergence of varieties was the result of a natural process of hybridization. He'd been working long and hard on breeding varieties that could withstand the harsh Swedish climate. He knew how to produce plant hybrids, even if they didn't always survive like he hoped. Well, by the 1760s, he had come to the conclusion that hybridization occurred in nature and that it had occurred in history as well. He reasoned that God had originally created only a relatively small number of species. It had been through hybridization that these gradually produced primordial genera, groups of similar species, had come about, and the process didn't stop there. In fact, Linnaeus considered this historical hybridization to go on at different levels. As the various species within a genus cross-fertilized, they produced varieties. But the cross-fertilization also occurred across the genera. When that had happened, new species were born. And that accounts for the many diverse species that eventually came into being. Well, I called your attention earlier to the phrase origin of species. That phrase has been made so well known by Charles Darwin that I want to be sure again we realize its precise meaning. It doesn't refer to the origin of life. It means that new species have arisen in history, subsequent to the original creative act that got things going, whatever that creative act was. What Linnaeus was concluding here was that new species had arisen since God's original creative decree. That decree, which Linnaeus did not question, had brought into existence a relatively small number of species. We get a sense for what kinds of species God created directly from the Genesis account. But God had not created back then all the diverse species that exist now. Those had arisen since the creation by the process of hybridization. They were, as Linnaeus put it, children of time. Now, if you look into early editions of Linnaeus's work, The System of Nature, you can find the sentiment there that there were no new species. Like most everyone, Linnaeus then believed that all of the species that existed had been directly created by God. But in the edition of the work in 1766, the words "no new species" were removed. That did not sit well with some. They couldn't go along with it. After his death, for example, Linnaeus's death, a German theologian named Zimmermann accused Linnaeus of atheism. So Linnaeus's son defended him. He insisted that his father believed that the natural order was the work of God, even if there were species that were the work of time. Now, I find Linnaeus's willingness to consider that new species had arisen naturally particularly interesting. The reason is that Linnaeus was no deist of the kind we've met earlier in this series. He was a devout Lutheran who didn't regard his conclusions as in any way inconsistent with his religious sincerity. That's why he's interesting. He's much more like Isaac Newton than someone like Buffon, whose theory of the earth we discussed back in Lecture 3. We mustn't assume, in other words, that all those who dedicated themselves to the study of nature, even those who assumed that they were finding out the natural means God employed in making nature what it had become, we can't assume that all of those were deists. Many, as I've mentioned, believed sincerely that their work in natural philosophy was bringing glory to the Creator. And even though Linnaeus was among the first to begin unraveling the notion that species had been fixed in place at the creation, he surely did not believe that he was in any way undermining God's role in history. I just mentioned Buffon. In fact, Buffon was critical of Linnaeus, but not because of his ideas about God. It was the classification system that bothered him. Buffon was another natural philosopher in the 18th century who concluded that species were not as fixed as most commonly assumed they were. But his conclusion about what had happened in history was different from Linnaeus's. He agreed that species had changed over time, but not the way Linnaeus imagined. Buffon worked primarily on animals as opposed to plants. He came to the conclusion that what Linnaeus would call different species were really variants of an ancestral form. So he didn't want to join in the general enthusiasm that Linnaeus's system of classification was enjoying. What he believed had happened was that the ancestral form had degenerated. That's the word he used. Why had they degenerated? Because when individuals changed locations, they encountered differences in external conditions like climate. And this caused them to degenerate into the diversity we now have. So degeneration was the alteration of species from an original primal form due to the influence of external conditions. Lions and tigers, for example, were degenerative forms of an ancestral cat. Buffon believed that practical reasons made it impossible for these degenerations to interbreed at present. But theoretically, if the external conditions that had caused the degeneration to occur were removed, the ancestral form would reemerge as quickly as it had degenerated. Just to remind you, these ideas of Linnaeus and Buffon about what we might call the mutability of species, the fact that they're not quite as fixed as was traditionally thought, these ideas were not the majority opinion. Most folks still accepted that God was responsible for creating everything that existed and that they had always been that way. So just like in the case of the novel ideas about the earth and its history, consideration of the world of living things brought with it challenges to widely accepted ideas. The easy understanding of living things as the result of God's direct creative decree was complicated by conclusions that God may have employed natural processes to accomplish his ends. As Linnaeus put it, some species may be the children of time. There's an important side effect of this insertion of time into the picture, and it's this. If these natural developments, hybridization, degeneration, occurred since the creation, how much time had they taken? This issue was especially a concern in Buffon's mind. He was one of those who began extending the age of the earth because it would have to take a long time to cool. But then that gave him plenty of time for things like degeneration to occur as well. We see here that the question of God's relation to nature was becoming more complicated. Where does the natural philosopher stop trying to figure out how God had produced this world around us and simply accept that God had done it? This question presented a dilemma for some devout natural philosophers. They were passionately interested in nature as God's handiwork, but others might question their devotion if their explorations into God's world uncovered ideas that were at variance with the traditional expression of their faith. This matter was bad enough in the context of the classification of living things. It wouldn't get simpler when attention turned to understanding how an individual organism grows. And we're going to see that in our next lecture.